Okay, so we are going to be looking at factoring polynomials of degree 3. This is just basically more practice from the previous lesson, which was lesson number 5. So when we take a look at a polynomial, my clues here is like, hey, there are 4 terms. 12 is divisible by 3. 48 is divisible by 3. 64 is a perfect cube. I'm thinking this is just a perfect cube, right, from Pascal's triangle. 1, 3, 3, 1. Right? 3 times 4 makes it 12. 3 times 4 squared made the 48. And 1 times 4 to the third made the 64. We're just looking at x plus 4 to the third power. Again, the keys, 4 terms. It ended with a perfect cube. 12 and 48 were divisible by 3. Okay, on this one, there's only 2 terms. But again, 64 is a perfect cube. So I'm like, aha, I'm looking at x to the third plus 4 to the third. So I just use my little equation here. Anytime I encounter u to the third plus v to the third, I'll need u plus v, and u plus v will become 4 plus x. U squared will be x squared. Now notice the next sign looks like it's flipped. That means I have to switch to negative. U times v will be x times 4, but of course we'll write that as 4x. The last sign is always positive. It's also plus sign at the end. V squared, well, 4 times 4 is 16. There's the answer. The time-consuming one is the factor by grouping. At first glance, I might think this is a 1, 3, 3, 1 from Pascal's triangle, but I noticed that 64 on the x is not divisible by 3. X squared does not have a coefficient. Number 1 is not divisible by 3. So this is factor by grouping. So I concentrate on the first 2 terms and I say, hey, you know what? The greatest common Triton, hush. The greatest common factor is x squared. So I can factor out an x squared. That leaves me x minus 1. Now I can focus on the third and fourth term and say, hey, from the third and fourth term, I can factor out a negative 64. That'll leave me x minus 1, right? Negative 64 times x makes negative 64x. Negative 64 times negative 1 makes that positive 64. Right, so I factored out the greatest common factor from the first 2 terms, the greatest common factor from the third and fourth term. Now I can use the distributive property. I'll have 2 sets of parentheses. Since the x minus 1 matches the x minus 1, that is one of them. If those did not match, this method would not be working. And then, of course, I've got x squared and a minus 64. This one will factor further. X times x will make the x squared. The negative on the 64 says the signs don't match. 8 times 8 will make 64. More precisely, negative 8 times positive 8 makes the negative 64. And of course, negative 8 and positive 8 adds up to 0 because there are no x's in the middle. And so those are one example of each of the 3 methods.